Welcome to EDIBON. For over 30 years, we have provided premier technical teaching equipment across the globe. Our product range covers most technical areas which include engineering, physics, electronics, communication, and renewable energy. Every EDIBON product is designed, manufactured, and quality controlled at our headquarters in Madrid, Spain under several quality standards. Today we will discuss the EDIBON UCP unit. This unit is a computer-controlled process system with an electronic control valve. It is designed to study the unitary process control of a system. The unit physically simulates dynamic systems under the operation of process, unit, and control loops. It has the capability of being used with the SCADA-NET teaching tool and with the Programmable Logic Controller. Now I'm going to cover the basic components of the UCP unit and demonstrate a practical exercise. This is the unitary process configuration for process control of the hydraulic circuit. This configuration consists of the UCP base unit, the control interface, in which each sensor connection has a different number of pins in order to eliminate any chance of mixing up the sensor controls. The control interface can be connected to one computer or it can be used with the SCADA-NET system. The unit is supplied with a SCADA computer control system which is patented by EDIBON and based on LabVIEW. The system includes the physical unit, the control interface box, a National Instruments data acquisition board, and a software package that allows computer control, data acquisition, and data management. The base unit uses the following sets. Each set includes the sensor and element and the computer control software for process control. Temperature sensor, level sensor, flow sensor, pressure sensor, also pH sensor, and total dissolved solids and conductivity sensor and element. The unit also contains a proportional valve for PID control, 2 centrifugal pumps, and 3 solenoid valves, 1 which is usually open and 2 that are usually closed. The software for the UCP unit is based off of LabVIEW. It can be divided into 6 sections. The first is the main controls, which include on-off, calibrate, view data, and quit. The second is the main control of the actuators, which can be analog or digital. This includes the pump and valve controls. The third is the sensors and extra output parameters. This gives us real-time data of all of the sensors. The fourth is the graph configuration, which allows you to select the data for the graph. The fifth is the graph itself, or it could be a table depending on the application and unit. And the sixth is the control options, which include manual control, on-off control, and PID control. Here is a better look at the control options in the software. Now I will demonstrate a practice exercise that is included in the manual. The objective of this exercise is to regulate the set point, or level in this case, by the use of the PID controller that automatically operates the final element of the loop, which is the control valve. Here is the main screen in the process control software. First select Start. This will prompt you to a dialog box where you will choose where to store the collected data. In the control options, select the option for PID control. Select the element that you are working with and enter a set point and PID constants. The integral constant should be small and the derivative large to prevent on-off action of the actuator. Then activate the PID control. You can see that the actuator is at 100% on the right-hand side of the screen. You must turn on the data save in order for the program to record. You can adjust the periodic or the time interval. You can also take data at a specific time by clicking the data button. Next, configure the graph. You can select 1 or 2 separate graphs. Select the sensors you would like to monitor and the set point. You can change the range of values on the y-axis of the graph to get a better perspective of the data. You can see the set point and the real-time level on the graph. Now it is time for some dynamic control. With the PID on and the pump on, the level in the superior tank increases until it reaches the set value. When it reaches the set value, the PID actuator located between the pump and the superior tank will close to prevent flow from the pump and providing a constant level. In the software, the graph displays the real-time value approaching the set value. It displays the closing of the PID actuator, and the PID action graph is displayed below. By opening the solenoid valve, you can decrease the level in the superior tank. Or you can open the manual valve on the unit. The level sensor sends a signal to the process control interface. The PID actuator is again opened, allowing fluid to flow from the pump to the superior tank. In the software, this data is collected and visible in real time. Once the PID actuator opens, you can close the solenoid valve. And as the level reapproaches the set value, the PID actuator again will close due to process control. Practice possibilities of the UCP system include, but are not limited to, process control of each individual sensor, which is integrated into the computer interface, allowing manual control loops, on-off control loops, PID control loops, and adjustment of the constant of sensor controller. Another practice possibility of the system is the use of the Programmable Logic Control. By using the PLC, PI, and the PLC control software, you can implement each process control. You can also control the system without use of the PC computer. This provides hands-on with the unit process, allows control of inputs and outputs, configuration of the processes, and programming exercises for PLCs. The fault simulation system allows the instructor to create errors in the system in which the student should identify and solve if possible. Some of the examples for fault simulation include incorrect calibration of the sensor, non-linearity of the sensor, inverse or quadratic, inversion of on-off controls, and the interchange of operation controls of the pumps. There are 3 available versions of this unit. The UCP unit, which is Computer Control Process System with Electronic Control Valve. The other 2 units, the UCPN unit, which includes a pneumatic control valve instead of the electrical control valve, and the UCP-CV unit, which uses a speed controller instead of the electronic control valve. Only EDIBON has a SCADA system that provides the following benefits: open control, multi-control, and real-time control. This means that at any time during the experiment, multiple parameters can be changed at the same time with instantaneous effect on the unit. Each unit has a specialized EDIBON control software based on LabVIEW to enable easy control of the unit. Calibration exercises which are included teaches the user how to calibrate a sensor and the importance of checking the accuracy of the sensors before taking measurements. Projector and electronic whiteboard capability allows the unit to be explained and demonstrated to an entire class at one time. The system is capable of being remotely controlled over the internet by the user or by an EDIBON technical support engineer. Each unit has 4 safety systems that are designed to mitigate risk for the user. This unit has been designed for future expansion, such as incorporate in the unit on EDIBON SCADA-NET system, which enables many students to simultaneously operate any unit in their SCADA network. The following is included with every EDIBON unit: 8 manuals, including a user manual that explains the scientific theory being studied, any related mathematical equations, the function of each component in the unit, and how the unit is operated. Each unit is designed and manufactured under strict quality control, which allows us to offer a 3-year warranty against any manufacturing defect and components control during the lifetime of the unit. Thank you for watching this video. A link to our website can be found in the video description below. For more information, please contact us by phone or email. We look forward to talking with you.